Hi, everyone, and thank you for coming to today's talk. My name is Allison Heinz, and I'm a program manager with the Swartz Center. Today, we have a great talk, so I'm going to introduce our speaker. We have Ehsan Totoni. Okay. He is an entrepreneur, computer science researcher, and software engineer working on democratization of high-performance computing for data analytics, AI, ML. Ehsan received his PhD in computer science from the University of Illinois at Urbana-Champaign, working on various aspects of HPC and parallel computing. He then worked as a research scientist at Intel Labs and Carnegie Mellon University, focusing on programming systems to address the gap between programmer productivity and computing performance. So I will let you get started.
Thank you very much. I appreciate it. And thanks everyone for coming in person and online. Great to be here. I actually used to work across the street from this building, so it's good to be back. Very exciting to see this building. When I was here, it was being built. I'm Ehsan Totoni, co-founder and CTO of Bodo, and I want to talk about a little bit of our journey at Bodo and some lessons that may help you in your own journey. And I believe these will address a lot of potential questions for you guys, but feel free to ask any questions during the talk. So who is this talk for, and why are we here? I get a lot of questions about entrepreneurship from researchers, graduates, computer science students or other related majors, and they just don't know when, what to do, when to start, what to work on the entrepreneurship line of activities, and they don't know how to bridge the technology and business gap. And this is where I was essentially some years ago, and these are the things I wish I knew when I was starting out, throughout my career, really, even undergraduate. So I want to share that with you guys, and hopefully it's useful. But first, let's define what I mean by deep tech entrepreneurship. What I mean is that you're a domain expert in some field, and you have either created some ideas or you want to contribute to some ideas in your area that will solve a real problem, and you want real world impact for your efforts, but you don't know where to start and you don't know how to bridge the gap of technology and business. To give you an example, a concrete example, when Google started out as a startup, it was a deep tech company. Two PhD students from Stanford had an idea of how to essentially evaluate web pages and links through their algorithm, which was called PageRank. And their idea was using backlinks to a page and things like that. And they wanted to really organize world's information. And that's how Google started. In contrast, Facebook was not a deep tech startup because the idea was using technology for solving a new problem, which is having an online directory of people. Now they are so big and so rich and powerful, they can hire all the scientists they want in the world, but the company didn't start as a deep tech company. So there is a contrast between types of startups. We are focused on deep tech startups here. So in general, bridging technology and business worlds is very challenging, and everyone's journey is unique. But there are patterns that I think apply to a lot of people, and I hope my story will help you. But please keep in mind that there is a significant survivorship bias here, and I survived until here, and I'm here in front of you. But please talk to entrepreneurs who didn't succeed. This is a risky business, and there may be a lot of great people who didn't succeed for various reasons, and their lessons may be very valuable as well, because it will give you the full picture. Over 90% of startups don't succeed, so you have to learn from those 90% plus people. But in general, I will argue that entrepreneurship is necessary for having real world impact, and you can't stay within science and technology world and hope others will pick up your ideas. You have to roll up your sleeves and learn about product, business, and make a difference. But first, what is Bodo? And what do we do to give you context for the presentation? So we are a new data platform for processing large data sets, big data in the enterprise. And the problem today is that development teams and data teams write code in simple scripting languages like Python, but then some other engineering team or IT team has to rewrite all the code into other languages, Scala, Java, with systems such as Spark, to scale it to production. So there's a big gap between prototyping and development and scaling in production. And these production systems are very inefficient in data infrastructure of companies. So what Bodo is a new platform. Oh, looks like some of the fonts are not available on this machine. That Bodo is what we call extreme performance Python platform, where the same Python code in development can scale to production automatically. So enterprises don't need to hire highly skilled people to rewrite the code and pay all of this overhead. And Bodo is much more efficient and saves a lot of cost and makes data pipelines and machine learning applications much faster in the enterprise. So that's very high level. Just to give you a taste of it, the Python code is written as usual if you're familiar with Python, but Bodo provides a JIT decorator, and we have compiler technology that optimizes and parallelizes the Python code all automatically. And to give you a sense of the kind of results we have in the industry, the most common system used is called Spark. And one of our customers, which is a very large tech company, Fortune 10 enterprise, they created a cluster in their cloud environment with 4,500 cores, 125 instances, a fairly large cluster, and tested a standard benchmark with Bodo. And they tuned their system as much as they could. But still, Bodo without tuning was faster by 20 times, which means they can do a lot of things in real time, and their cloud cost is much lower. So our technology is a new kind of compiler that has capabilities that other compilers didn't have. If you write code in C, the compiler translates your code directly to sequential code. But Bodo takes Python code, understands the structure of it, and optimizes and parallelizes it to an efficient parallel version of the code that can scale on large clusters, just like supercomputing applications scale. So brings high performance computing to the enterprise. And this is one of the fundamental computer science problems called simplicity performance gap that we have solved for the first time. So that's why we believe we are a deep tech company, and that's our frame of mind in terms of building the company. So at a high level, this platform supports open source APIs and can run on any infrastructure and can load data from any storage and allow users to process it. It could be terabytes of data, it could be thousands of CPU cores on any infrastructure. So that's who we are. But let's talk about the journey to here. And I will start from my undergraduate years. When I was starting to learn about research and high performance computing. So I was very excited about high performance computing. I was in Sharif University in Iran for my undergraduate, and I joined an affiliate institute working on abstract math and physics problems. So they were just starting to use computational methods to solve these problems instead of just writing proofs by hand or things like that that mathematicians and physics researchers do. And we didn't have access to resources. So what we did on the computer science side is we bought a bunch of these PlayStation 3 consoles. At that time, there was a processor called Cell BE from IBM that was the most advanced processor. And it happened to be inside this console too. So it was the cheapest way to build a little mini supercomputer at the time. So we put together 12 of these, installed Linux on them, and started solving problems. So these things were really hard to use. The code, writing code for them was very difficult. And we started with a problem in math combinatorics, as several problems in graph algorithms and other kind of combinatorial problems where you had to really count various things to prove properties of these certain graphs or certain mathematical objects. And there were open problems that no one could theoretically figure out these numbers. So we were trying to use computational methods. And for one of the problems, I wrote straightforward C code on a regular CPU, and I calculated at this rate, it would take 530 years to solve this problem. So it wasn't practical. So what I ended up doing was used a new method, create a new method where instead of counting each object inside a register of a CPU, which is a 64-bit, for example, integer is one value, and inside the processor, these two values are counted. I packed the objects into bits, and this processor at that time had longer processor registers, internal memory that could hold 128 bits. And with this new algorithm and new way of doing things, I could solve this problem in 22 days. So we got the numbers. And later, GPUs came along, and we could do it in four days or something like that. So we got these numbers for the first time that were not available before. And I was essentially a hero in that computational science division because I solved the first problem for them that they were, trying to get some recognition. But I wrote my paper, got to the PhD program I wanted. So all good for an undergraduate, but in some way I didn't succeed because the users who would be the mathematicians, they took the numbers, they liked them, maybe they looked at them, but they didn't just focus on this way of doing things. I didn't change their mindset of doing their research. And they told me, okay, you got the numbers, sit down and prove them. I'm like, what? I'm not a math student, right? So that was my first lesson that research and solving the technical problem is just the first step. You really have to understand your customer and the personas of people within that customer organization to make a big impact and lasting impact. And solving the technical problem is just really a small part of it. I wish at that time I had a more product and business mindset, even for my research, even in a research institute dealing with mathematicians working on abstract math problems, right? So that was the first stage. Then I started my PhD at University of Illinois Urbana-Champaign and worked on various HPC problems. UIUC is really the hub for HPC. We had the biggest supercomputer on any university campus and creators of some of the supercomputing technologies. So pretty exciting place to be. The first project I worked on was when they were building this big supercomputer called Blue Waters. I started using simulation to design algorithms for the machine before it's available. Because these are very expensive machines, hundreds of millions of dollars. The software for it ideally should come before the machine is built. Otherwise, you're wasting a lot of resources. So my first work was building this simulator and designing new communication algorithms for the supercomputer, which was successful, but IBM decided not to build the supercomputer. And they pulled out of the project, and NSF gave the project to Intel and Cray. So the business side of things really impacted the research and made the research not as exciting as it could have been. So I switched to other problems. Solving the problem of power consumption of supercomputers was very hot at the time. So some of the research along those lines, parallel algorithms. But in every instance, for example, I wrote the paper about how to save cache power in processors, and I thought it made perfect sense. And I wrote the paper, top conference, got the recognition as a PhD student, but I couldn't get Intel to change their processor, right? In some way, it was not as impactful as it could have been. Another instance on parallel algorithms, one of the hardest problems was solving triangular systems which arise in a lot of computational problems in parallel. Very difficult parallel algorithm problem. And I created a new algorithm, wrote the paper, got some awards. I went to ACM award ceremony where they give out Turing Award. It was pretty cool, but I didn't get this scientific software community to change their software. It was just the first step. It would have taken years to change that. So pretty good on the research side, but not really the kind of real world impact I wanted. You know, when I was at CMU, I heard from a lot of students about, hey, I want to write a quick paper. And I wish I didn't write so many papers. I wish I had written less papers, but made some of them more impactful by paying attention to the business side. And by business, I mean in the general sense, and make them into some products and change what's out there. So that was the other lesson of, you know, you really need to think about business from the beginning, and research is really the first step. You know, I believe these papers are just sitting there, and there is a low chance somebody would pick up these complicated things and implement them. And that's the reality. So I joined Intel Labs to work on one of the most important practical problems I knew, which was the fact that high performance computing was really limited to national labs and certain universities. And this is the work that eventually led to Bodo. So I started there early 2015 and started Bodo mid 2019. So over 4 years of research led to Bodo. And I was at Intel Labs in Bay Area, and along the way, I moved to Pittsburgh and Carnegie Mellon as a researcher in residence in CMU. That's how I ended up in Pittsburgh and ended up staying. But we started building our technologies in Julia, which was the cool new programming language from MIT, and it was supposed to take over the world. So I spent over 2 years just learning this language, all the internal details, you know, evenings and weekends, just so much effort, but the language didn't take off. And I thought Julia is a great language and better than others, but it didn't happen. But the reason was that the alternative Python, from a product point of view, was better. Julia could be the better technology, but Python was the better product for the customers who would be developers. Even though it's free, it's a product. And the value proposition of Python was much stronger. Simple language that has such a large ecosystem and is mature. Julia didn't have that software ecosystem. So that was the problem. And we switched to Python and we were successful because of the Python wave just kept growing. So that was the research at a high level. But again, to give you a little more context, this problem in computer science is often called simplicity performance gap, where simple code is easy to write, but it's very slow, and single core doesn't scale beyond a single CPU core. But fast code is very difficult to write, and you need to learn MPI. It's Fortran, C++ typically. So it was very difficult line of research because it has never been solved before. And it was pretty exciting to have a solution for this. But along this journey, a system called Spark emerged from UC Berkeley, right? And it was very successful in open source. Eventually, the founders from UC Berkeley, students and faculty, started a company called Databricks, and now it's valued at $38 billion. And they are going IPO very soon. These are just astronomical numbers, right? Extremely successful in practice and commercially. But the problem was the software from technical point of view was not great and is not great. Parallel computing people didn't like it. Database people didn't like it, right? And they would use the words like nauseating or something like that. They hated it so much from the beginning. They still do. But, and I didn't understand why this is so successful. But what I understand now is that it was a product. Don't think of it as technology. Up to this day, I'm answering questions from even CMU faculty here in computer science. Why is this thing so successful? Why? It doesn't look good. It doesn't perform well. But I have to explain it's a good product. It's not the best technology, but there is no better alternative for the users who need the features. So you have to think along those terms. And the people who built it, their backgrounds was not parallel computing, was not databases. It was kind of distributed systems, OS networking, and solve the problem that way. But what those guys got right was the fact that they were thinking in terms of a product, even though they were academics. And they were thinking in terms of marketing, how to market it to the target user, what is your go-to market, and those sort of things that academics don't usually do. And because of that, they are so successful, both academically, because when you write a paper to a journal or conference, and your software is so famous, they're going to accept your paper. Doesn't matter what the ideas are too much, right? And one of the founders is now, professor, MIT, Stanford, whatnot, because of that. I don't know about their other research, but this is probably a major factor. And because of this, these guys, professors and the co-founder students, they are now billionaires, okay? And UC Berkeley, when they want to build a building, I just heard they launched the building, and the way they did it was, this professor put down 30 million, this other professor 30 million. These guys are just killing it over there because of this change of mindset that they did. And I believe some of it could come to Carnegie Mellon as well, this kind of mindset. And there's a lot of success that in the real world that is waiting to happen. So that was one of the major events during this time. And we realized we have tough competition, and we have to focus on replacing Spark with what we thought was the right idea. And that's our mission today. And we are just starting. And we are going against the giants now. But another event that happened was deep learning came along and became just so prominent, this AI revolution and all the hype. And the way it started was that in 2012, somebody figured out that some of the old ideas of neural networks, if you bring them back with enough compute power, the graph on the left, one of the standard image classification benchmarks is going to be improved significantly. So this started the whole process. And, this benchmark just gives you a lot of little pictures of objects and you have to classify them. So that was it. And we did some work as well. The paper on top is from us at Intel Labs. I was a part of the team. And we had a very smart student from UC Berkeley who did a lot of the work. So we were doing okay, but I decided not to continue working on deep learning because I thought, yes, this is pretty useful, but it's a huge hype. It's not going to take over all applications in the world. And also the problems from my point of view, from my area's aspects are not that big. And others are working on it. They're going to solve it sooner or later. So I didn't continue working on deep learning, and I'm very happy I didn't do that. Because for doing anything significant, it will take you years and it has to be worth it. Never start something small. I believe you should start working on big problems and they will take years, but it will be worth it. If you start on working on simple problems, you're wasting your time. It's not going to matter too much. So continued the research, and the little prototype that came out of it was called HPAT, High Performance Analytics Toolkit. That was one of the terrible names Intel would make you choose for your projects because of their rules. So I finished the research, it looked good, wrote the paper. I thought this is a big breakthrough and it's gonna replace Spark. So as an academic, I started giving presentations wherever I could. So actually I came here before moving to Pittsburgh. It was in 2017. I came here, gave a talk. I went to MIT as part of JuliaCon, invited the database professors, gave a talk. Wherever I could, I gave talks, and everyone said the same thing. Yeah, the ideas make perfect sense, right? But why is the Spark thing so big? I don't understand. So the commercial success of some ideas really overshadows the academic mindset too. Academia is not just about ideas and technology. So you have to be successful commercially. Otherwise, they're not going to take you seriously, even here in a university. So that was a big lesson. You can do all the research you want, but business is going to impact academia. It's not always the other way around. And I learned that you can't really expect a lot of collaboration in academia to join forces with you. It's really individual endeavor. There's all this collaboration, kind of ideas being thrown around, but a lot of it is really professors doing their own thing. They're not going to change, even no matter how great your idea is. It will be difficult to find people to join forces with you in academia, but in business, that's a different story. So very, very valuable lesson that you need to win in the marketplace for your technology to survive. You can't just stay within the technology realm. So I tried to see what I can do inside Intel, right? They hired me as a research scientist to build technology. So now what? I built it. Let's do something with it. Around the same time, NVIDIA was putting a lot of pressure on Intel, trying to get Intel's market share in data processing and in the cloud. So some very similar software came out, a lot of interest from different groups. I was invited to so many meetings, and weird time zones because Intel is a global company, but still nothing came out. And that's where I learned in a big company, because of all the politics and the structure, it's not really easy to make something new happen. It just didn't fit Intel's business model as a hardware company. And one of the key moments was that our kind of lab head, a very influential person inside Intel, he was very supportive, right? And he supported my research all these years. But one day he got just frustrated. He's like, what do you want me to do? We are a hardware company. Why did you hire me 4 years ago? That's the case. So just didn't fit the business model. A public company is an engine going in a direction. You can't really change that. So that's when I started thinking about coming out, and they encouraged me at Intel Labs to do that. And I moved to Pittsburgh partially because just getting out of Silicon Valley is ironically better for starting a business because of cost of living. And you don't have a salary for a while, just looking for individual health insurance and those sort of things I had to do. So economically made better sense to live here than Bay Area. So I did the opposite of a lot of what a lot of people do. And around the same time, a VC actually contacted me, and they invited me to their office for a meeting. And it was pretty interesting. They just saw my paper, and I thought nobody reads those papers. So it was interesting, those guys did. And they were really specializing in finding kind of deep tech PhDs working on new ideas and funding them to come to the market. So sounded pretty good. But when I went there, I couldn't really communicate with them. I couldn't talk business. I could talk technology and explain those things. And they had read my paper and tried to understand the area, but I couldn't articulate what the product would be and what the business model would be, what the go-to-market would be. So to this day, they haven't invested in Bodo, okay? So I learned a lesson that just there's a long way to go, and I really need to learn a lot of things to make this happen. So that was when I met my co-founder, Behzad Nasri. The way it happened was that I talked to one of my friends who had started a company. I just knew few people who had started a company. So talked to my friend. By the way, his startup didn't work out, just to give you an idea of a lot of things that fail. And he introduced me to Behzad. Behzad was his advisor, company advisor, and Behzad was essentially angel investor and startup advisor. So I talked to him as a potential advisor and just wanted advice and get him involved, help me. But turns out before kind of retiring from Intel and becoming angel investor, he had a long career at Intel actually. And he was at Intel Capital, part of the team that invested in Cloudera at the time. This was one of the famous investments at that time, $740 million, one of the largest investments at that time that went sideways, didn't work out. So one of the famous failed investments in Silicon Valley. And because of that, he knew the challenges of this area, and he knew this idea could be huge. That's why he decided to join in as a co-founder and started the company. And just to give you the mindset of whether you should have a co-founder or not, have this person or not, I asked my friend, the founder friend, this question. Hey, what do you think about joining forces with Behzad? And he said, I'm not going to give you the answer, but the framework is that if you start with him, will he double the value of what you will be doing long term? And the answer was very clear, yes. So this is the framework for finding co-founders and who should be your co-founder. So that's the way I thought about it. A lot of technical people will think like, oh, you have a business person, but he's not coding. What is he doing? Just don't think that way. It's about long-term, will this person increase the value of the company? Doesn't matter what they do day-to-day basis, thinking about various ideas or meetings or whatever they are doing. So that was the time I had to communicate with a business person, and it was extremely difficult as a technologist to do that. We were just in different worlds, right? And it just needed practice. And fortunately, he was very patient and good at talking to technologists, and that made it easier. And what else made it easier was the fact that because he was previously at Intel, I could understand his resume better than other business people. And I was very impressed with his accomplishments. In Intel kind of business, getting some OEM distributor to use Intel processors in their servers and just make Intel their standard. Huge deals like that that he has closed and worked on. So I could understand that, and this trust actually helped me work with a business person. So that was very, very helpful. We spent a lot of time working on potential product, learning about the market, competition, and it was his first time in this area too. So a lot of learning. It took several months, a lot of slide decks being sent around, and a lot of meetings and talking to VCs and so on and so forth. So I left Intel. I still remember the day I walked across the street here from my office and started thinking about what to do, how to set up office at home and things like that to start Bodo. And we started fundraising, which was extremely difficult. You may have heard you have to talk to 100 VCs to hopefully get one. And it was true. We didn't fit patterns that VCs are looking for. So it was very difficult. We were fortunate that our first customer ended up being this large tech company that have really helped us grow as a company and helped our product advance. So that was very useful, but very difficult to get them excited with the prototype. So we had to put together a product out of nothing, something that would work in their environment. And the reason a big tech company was able to even use it was the fact that they were advanced enough to build the rest of the solution themselves and plug in the technology. And they were really looking for this exact same thing. They were stuck. Otherwise, why would they talk to a two-person startup, right? So we were very fortunate, and they were visionaries, the people we talked to. That was pretty important. Otherwise, big company people are not going to understand what you're doing or care about what you're doing. You have to really find visionaries in your customers. But the hardest part was hiring. I think in the startup journey, in this kind of deep tech startup, hiring the right people who could make a lot more money, be much more comfortable in a big company like Google is very difficult. How do you convince them, especially very early stage, to join you? It's a biggest challenge. Even to this day, I think hiring is the biggest challenge of Bodo, because we need really top talent. It's a deep tech kind of a situation. So that's very difficult. And we started working on our first partnership, which was with Intel. Intel was interested in having an open source version of the software to compete with NVIDIA. But we failed to do a partnership. We invested a lot of time in it. And it was a big lesson that in big companies, there is no one voice of the big company. There are a lot of people, they're playing their politics, and you may get burned in the middle of all of that. So make sure they don't waste your time, and the interest is real. Otherwise, they are not going to lose anything. They are getting their salaries and they are going by their business. But you may lose in this situation. So build the first team, and our office is still in Bakery Square. There is a shared office space that's pretty good for startups in the Google building. Very nice building, and it's very good to interact with other companies and even not-for-profits, and not being a tech bubble. I really like that space. So we passed this stage, but what ended up happening was getting the second customer was extremely difficult. We would do long proof of concept projects with the data science teams of various large companies, and we would get performance. We would get the results we thought were amazing, but we couldn't sign a deal, just not possible. And we realized data scientists are the wrong persona for the software. We have to go after bigger problems, data engineering, because the moment we said Python, everyone thought about small problems in data science, not the big problems that they would pay for. They wouldn't pay for anything Python. So we had to really change their mindset. So we understood, I personally understood the importance of understanding your use cases, understanding the customer and the persona within the customer. Who's buying this and why? It's not an easy question to answer. Very difficult kind of questions. Another case was that we gave the result they wanted to the data team, and the managers were very happy, saved their cloud cost, very high performance, but we couldn't close the deal. Why? Because the IT team, DevOps team, wanted a simple GUI user interface to click on something, create clusters in their cloud and whatnot. They weren't willing to write code or things like that. And because of that, we just couldn't close the deal. So it goes back to importance of product versus technology. And you have to have the right features to be able to sell and be successful. So fast forward, earlier this year, we raised our Series A financing led by Dell Technologies Capital, who are one of the best investors in our area, I believe, based on the companies they have supported. And they have been really great with us. They have helped us significantly in various aspects. And we treated this as our company launch, because that's what it is. And we really worked on our product messaging, the use cases, the personas we are targeting, and we are still working on that. It's in work in progress. And I still think we have a long way to go to clarify those things. But in general, when you build a larger team, just things change, new challenges arrive. This picture on the right is our larger team, part of the team, in the brief moment when we thought COVID is over in the summer, before it came back. So we got together, and really amazing people helping build the company. Early employees are extremely critical for building something new. And we got on TechCrunch, and we did all the right things to raise our profile and really be known out there. But building a larger team, you really need to define roles, really work on communication challenges between different groups and things like that, I didn't know how to do that. So it was a learning experience to do that. And right now, what we are working on is a large deal with an enterprise, and a couple of these deals, and a major partnership with one of the biggest names in data infrastructure. So if we are successful, I'm going to come back here and give you an update after raising our Series B. So the journey continues. It's a very long journey. So that's where we are. But kind of taking a step back and talking general terms, in terms of what I think as a technologist you should think about, or working with technologists, it's really the difference of technology and product. Technology is good. You can write papers, you can show it off in certain venues, but customers need products, and you have to check the boxes, and you have to find the right customer. Not everybody will understand what you are doing. It's very difficult to communicate what you are doing, and you have to give them something that really works for their use case and solve their problem directly. Right? A lot of technical people don't understand this. And related to this is go-to-market, which is what is your target market for this product? What is the value proposition for the users to buy this? You really need to think about that. How are you messaging to them why they should use this? And what are your marketing and sales channels to get to those target customers? What is your pricing? All these go-to-market aspects need to be considered. And I think you as a technologist need to understand this because these are all related to the technology. And if you can't work on the business aspects, your odds of success will be much lower. And you can't really offload all of these problems to a business person to deal with. You need the right business people with you, but you have to contribute to these as well. And I think you need the right advisors and partners and co-founders to help you with all of these aspects from the very beginning. I have seen a lot of people building something before knowing what they want to do. And it can be a huge waste of time. But I really believe that not everyone should start a company. If you want to be a deep tech entrepreneur, you could be an early employee of a startup, successful startup, and build something very successful and important. I've seen a lot of people who really want to start companies and be founders, and I kind of feel like it's because of ego, not because of love of entrepreneurship. So make sure it's not your ego. For example, I've seen students here right across the street who say, I want to start a company and do what you did. I just look at them, okay, what is your idea? What is your technology? You just like being a founder? That's not entrepreneurship, right? Go out there and have some impact. And I think the best time to join a startup is right after graduation. And the reason, kind of talking about the difference of startups and big companies, in a big company, you will get comfort. You join Google, whatever, there's a big brand, everything is taken care of, everything feels comfortable when you walk in, your role is defined. But on the other hand, your role is narrow. You're one of 100,000 people, right? They have to define the roles to manage the company. And because of so many people, it's human nature. There is going to be politics when there's a large organization and everyone trying to reach the top. There will be competition, politics, and it can be frustrating. And because of that, you may have co-workers who are not motivated. I think for me, working at a big company, that was the worst part. I have some co-workers who don't care. They just look at the company stock going up and down because they believe their work doesn't matter, and they could have been right, and just didn't want to make an impact. For my type of mindset, that was really frustrating. So that's the reason to join a startup. But in a startup, you can have high growth, but on the other hand, your role may not be very well defined. You may need to do various things, and things change all the time, and it's not comfortable. You have to go with your eyes open, and you have to go to a good startup. And I will, next slide, talk about what is a good startup, right? So in a startup, you can have high impact. Your voice is heard. You are not 20 levels below the CEO. You can have high growth, but there is risk. It may not be successful. It's not comfortable. The risk aspect of it, I kind of don't understand it too much. People say risk for employees because if it's well funded, it's not like you're going to be out of the job and you can't get another job. Yes, your stock options go away if something happens, and that's it. It's not a huge risk. So anyways, I've heard from a lot of students here, I'll go to Facebook and join a startup in 2 years. Never happens. I've never, ever seen it happen. I see somebody laughing. That's definitely true, because when you join a big company, it's like a cult. All the colors, all the perks, everything is designed to lock you in. Even the salary is designed to lock you in, because they will pay you above market rate to keep you, but you can't grow to increase your earnings. So long term, you may actually lose out on earnings too. And more importantly, I think the life experiences of different environments, you will lose out on those experiences. So really think long and hard about your options, and just don't say, I'm going to change in 2 years. You will get used to it, and you won't accept anything below what that big company has to offer in terms of salary and perks and things like. You just get used to it in 2 years. So anyways, but I think it's very important to evaluate startups properly. Not all startups are good startups. Just find good startups to join. And it's very different, especially if something is deep tech. And you should really think in terms of an investor, because you are investing your time in the company. It's more important than investing your money. The way investors evaluate companies is 3 factors. What is the market? How large is the market? Is it ready for something new? What is the technology of this company? Do they have any technology advantage to win? And who are the people? Can these people achieve this? So I recommend thinking in these three terms. And if I want to advertise my company, is the market is huge in data infrastructure. There's a lot of problems out there, and the valuation of companies in this area, startups in this area, shows success of them shows how big the market is. The technology is unique and new and differentiated, as I mentioned. And the people, I believe we have amazing people, right? That's how I pitch my own company. But VCs don't know all these technical aspects. You're better than VCs at evaluating startups in many ways. You can evaluate technology better than them. They're not expert in technology. They typically have some business background and they rely on other technologists, so they don't know. And they are not good at evaluating people either, because they don't know the technology and they don't know if this person is expert in it or not, in this area or not. And they may use things like the number of Twitter followers or something, right? Or this person is famous. So they are looking for patterns, and that's what it is, because they don't know the technical details, but so you can evaluate startups better than VCs. Just don't go after who got the most funding. But VCs understand the market very well. So they pay for data actually, and they analyze the market. So however you can understand the market from VCs, that's going to be helpful. So that's how I would recommend you should evaluate startups, and not just join a startup because it's a startup, because a lot of startups will fail, and you can tell if the startup has a chance or not, more so than a lot of VCs. But I think in general, you should from now try to understand who you are and who you want to be. What is the problem that you're passionate about, and what kind of impact you want to have? And that will shape a lot of your actions and what you will focus on. And try to communicate it to others to find your community. You need a lot of people to work with as partners, co-founders, customers, cheerleaders of your company, help you successful. And I wish I had done that better, communicated what I care about and my area of interest better. And I wish, for example, I use social media better. That's a tool, right? Not random followers, but understand where the community is and be connected to them better. That's something I'm working on. So I recommend starting to do that now and really find your voice. And build a network starting here in Carnegie Mellon. The people sitting beside you will do amazing things, right? And you need them later. Just make sure you build a strong connection to work together later as well. This opportunity won't come to you again, being around so many amazing people. But in general, I really encourage you to think in terms of having a positive impact. You're sitting here, I think you have been fortunate, we have been fortunate all to have this opportunity, and we have to give back. So don't settle for small problems, work on big problems, and try to make a big impact in some practical area around you. And you don't have to go too far to make an impact. And if you're excited about these problems we are solving at Bodo, please check out our website and send me an email if you're interested in the kind of thing we are doing. And if you're interested in the software, you can try it for free, and we have free academic licenses as well.